Hey, I'm Colt McCarthy, CEO of Republic Drill Co. Today we're going to talk about the loop loader. Before we start the loop loader in the morning or before the shift starts, we want to make sure we check the oil level here next to the fuel filter. We want to make sure that we have adequate coolant in the system. Halfway is a good place to start. We also want to inspect for any hydraulic leaks, engine oil leaks, or fuel leaks, or coolant leaks before starting the machine. And we also need to check the hydraulic oil level. We want the oil level to be no more than 3/4 full, but also it needs to maintain visual level in the sight glass. Before we start for the day, we also want to inspect the chain tension of the coil reel. We do this by visually inspecting the sprocket on the reel and the motor, the chain condition, and the chain tension to make sure that we have adequate chain tension. To operate the loop loader, it's very simple. We turn on the ignition. Once we have power to our screen, we continue on the start. Release the key once the unit is started. To control our RPM, we'll use this toggle switch. Up is increase. During operation, the recommended RPM is 2,600 RPM. One of the features of the loop loader is a tethered remote for tramming. This allows the operator to keep a safe distance from the tracks or any other objects that the operator may become pinched in the sudden movement of the machine. To operate the tracks, we release the red button, which gives us a red light, and a green indicator saying that the control has power. The controls are proportionally adjustable. Up is forward, down is back. When we're done positioning the loop loader, we push the red button in to disable the remote and place it back in its storage holder. In the event of an emergency or the damage of the control, we have hydraulic valves in the manifold. Install the levers, thread them in. Once the levers are installed onto the manifold, you can manually operate the tracks in the event of a damaged controller or damaged wiring. Once we're centered over the hole, we will connect the ground source heat loop to the coil tubing. We've already installed our adapter with a bolt. You simply slide the bolt up into the coil tubing, and then we apply some tape around the coil tubing and the ground source heat pump loop to maintain traction as we go down the hole. The gauges on the loop loader give us basic information about what's happening not only to the machine but also in the hole. We have our multi-display engine parameters here. We have our analog fuel gauge. We have our reel pressure that tells us how much or how little pressure we are applying to the coil tubing reel to keep it in tension. We have our injector head that is going to relate how much pressure the injector head motors are receiving as we run the coil tubing down or out of the hole. The higher the pressure on the injector head gauge, the more force we are applying to the coil tubing going down the hole or out of the hole. The system pressure indicates the hydraulic pressure that the system is using. We use that to check any of the functions as we stall them out to see what the maximum pressure of that function is doing. The first step to operate the coil tubing unit is to engage your coil reel. We will move the lever up to the end position. The next thing we look for is reel pressure. We want to see at a minimum of 800 psi on the reel pressure. If you do not have 800 psi, we will adjust the reel pressure relief until we see 800 psi. After we have the appropriate reel pressure of 800 psi, we can disengage the reel brake. Currently, it is left into hold, and we will move the toggle right to wind. You'll notice when we release the reel brake that the reel spun backwards as we are applying tension now to the coil tubing. If we ever begin operations with our reel brake off, the reel will begin to unwind on its own based off the sprung energy stored in the coil tubing. Now that we have reel pressure of 800 psi, we can begin to inject the coil tubing down the hole. To do that, we control the injector head, labeled head. The lever moves down for out of hole and up for in hole. When we move the lever up to in hole, the coil tubing proceeds down the hole. The speed of the injector head and coil tubing going down the hole is proportionate to the position of the lever. All the way up is maximum speed, all the way down is maximum retract. When we're going down the hole, we want to make sure that at a minimum our coil tubing reel is centered on the gooseneck. One of the critical processes to maintaining long life of the coil tubing is to maintain a good reel spool. It operates like a winch. We want the coil tubing to spool across the reel evenly and not be overlapping, reducing the life of the coil tubing. To control the coil tubing reel as we're going in hole or out of hole, we have the coil reel left-right lever. When we move the lever down to the right, the coil tubing comes towards us. When we move the lever up to the left, the coil tubing reel moves away from us. Depending on how the coil tubing is wrapping around the spool, you will move the coil reel to the left or right to maintain a tight pattern. The loop loader also features a hydraulically controlled ground source heat pump reel for facilitating the loops to go down the hole or to come back out of the hole in the event of refusal. The loop will free spool as the hole goes down, but in the event that we need to rewind the loop, we would move the loop reel lever to out, and it applies reverse pressure on the loop. If you want to use the retract of the loop reel, you have to secure the ends of the loop reel to the reel frame. To operate the arm on the front of the loop loader, we have down and up. Move the lever down, our loop reel moves down. Move the lever up, the loop reel moves up. When we park the loop loader, we always put the traction valve closed, which is facing horizontal. When we turn it vertical, when the unit is operational, we receive system pressure to our traction cylinders. This cylinder provides traction to the coil tubing going down the hole. We can increase or decrease the amount of force applied to the coil tubing by adjusting the relief at the bottom of the manifold. When we turn the valve out, we reduce the pressure on the coil tubing. When we turn the valve in, we reapply pressure to the coil tubing. This needs to operate between 700 to 900 psi to apply adequate force to prevent slipping of the chains and the coil tubing. Before we stop operations or walk away from the unit, it's very important that we apply the reel brake to hold. Now we can remove our coil reel back to neutral. At the end of the shift, it's important to disconnect the battery switch.